All right, Wildcats, here we are, day 1 of Volcanoes, Chapter 4, Lesson 4, page 160. Now, this is going to be a long one because there's an extra set of pages. So we're going to have to figure out how to spread that out, make sure that we stay focused and get it done. First thing's the same, write your name, AVID 6. Monday is going to be January 4th, 2021. Science FNT, Phase 4, summarize. At this point you should know how to spell everything. Chapter, CHP, period 4, lesson, LES, period 4. Okay, let's go ahead and get our blue pen. Volcanoes, capital V, O-L, C-A-N-O-E-S. Main, capital M-A-I-N, idea, capital I-D-E-A, slash, capital E period, capital Q period for the essential question, colon. Volcanoes form where magma reaches Earth's surface. So magma, M-A-G-M-A, reaches, R-E-A-C-H-E-S, surface, S-U-R-F-A-C-E. Okay, so volcanoes form where magma reaches the surface. All right, vocabulary terms. Cinder cone volcano. Cinder, C-I-N-D-E-R, cone, C-O-N-E. We're going to drop the word volcano because, well, the entire chapter is about volcanoes, so we don't need to say it again. Okay, where is cinder cone? Page 162. Here we go. A cinder cone volcano is a volcano with slopes made mostly of rock and ash. Okay, so I need to fold my paper in half. Slopes, S-L-O-P-E-S, equal rock, R-O-C-K, and down 3 down, ash, A-S-H. What else? Cinder cones are the smallest volcanoes, usually no more than 500 meters high. Most have deep craters at their summits. Okay, here's a picture of a cinder cone volcano. So rock and ash, and they are the smallest, I believe it said. Yep. Slopes equal rock and ash, zoop. Smallest, S-M-A-L-L-E-S-T. Next vocabulary word, composite volcano. Composite, C-O-M-P-O-S-I-T-E. Well, I know from this word composite means to compose or put things together. Composites are going to be like more than one type of volcano. Page 162. A composite volcano is composed of alternating layers of lava and ash. Alternating, A-L-T-E-R-N-A-T-I-N-G, layers, L-A-Y-E-R-S, lava, L-A-V-A, slash ash, A-S-H. So sometimes a layer of lava gets laid down, sometimes a layer of ash gets laid down. Here's an example of what that might look like. You can see the banded stripes. So sometimes it's ash, which is like the little flaky stuff in a fire. Sometimes it's lava, which is the magma reaching the surface. Okay, what else? I think that's pretty good for now. Oh, cone-shaped. I guess that could be important. I don't know. We'll find out. Island arc, page 161. These volcanoes may form a string of islands called an island arc. The Aleutian Islands of Alaska are an example. Let's see. Okay, let's go further back. Volcanoes build up from the ocean floor. Oh, okay. So island, I-S-L-A-N-D, arc, A-R-C. Let's go look at some pictures too, see if we can find an island arc. Where do they have it? Here we go. Hawaii Islands. Okay, they are like an island arc. And there's the Aleutians up there in Alaska. So, it's a chain, C-H-A-I-N, of islands, I-S-L-A-N-D-S, and they are built up from the ocean floor. Okay, go down and indent. Built, B-U-I-L-T, up, U-P, from, F-R-O-M, ocean, O-C-E-A-N, floor, F-L-O-O-R. Okay, lava, L-A-V-A, lava. Lava is magma that reaches Earth's surface. All right, there you go. Let's just draw a little picture. There's the surface. Underneath is magma. But if it comes out up on to the surface of the Earth, now it's lava. And that little part right there is the surface, S-U-R-F-A-C-E. You know what? There's the sun right there. Yay! Smiley face. Happy! Shield volcano. Okay, shield. S-H-I-E-L-D. I bet you anything it's in the shape of a shield. A shield volcano has a gentle slope made almost entirely of layer upon layer of lava. Ah, okay. Gentle, G-E-N-T-L-E. Slope, S-L-O-P-E. Indent, layers, L-A-Y-E-R-S, of lava. Okay, so here's a shield volcano example down here. Notice how it's much shorter and the gentle slope because it's all lava. So instead of big giant piles of ash coming out and piling up quickly, making it steep, the lava just flows out nice and slow and smooth, and it has time to flatten out. So that's an example of a shield volcano. Okay, so let's go back to the composite and the cinder cones then. Remember how they said they are cone-shaped? So let's go back to here, composite, and say cone, C-O-N-E, dash, shape, S-H-A-P-E. Okay, now we can finally start taking some notes. Inside a volcano. Inside, capital I-N-S-I-D-E. Volcano, capital V-O-L-C-A-N-O. A volcano is an opening in Earth's crust through which melted rock, hot gases, rock fragments, and ash reach the surface. Okay, melted rock, that's the magma and lava. Hot gases, rock fragments, ash. That's like the little flaky stuff in a fireplace. Gas-filled magma rises toward the surface because it is less dense than the solid rock around it. Okay, we already learned that when we learned about plate tectonics and we learned about convection currents. Near the surface, magma can burst through an opening or a weak area in the crust as lava. Lava is magma that reaches Earth's surface. Okay, we already have that over here. Over time, the cooling lava can build up around the opening, forming a volcanic mountain. Such a mountain is also called a volcano. Okay, so inside a volcano, let's see, magma, arrow, M-A-G-M-A, arrow, lava, L-A-V-A, colon, builds, B-U-I-L-D-S, volcano, V-O-L-C-A-N-O. So magma flows out onto the Earth's surface. We call it lava, and that builds up over time to make a volcano. In this picture, you can kind of see those layers building up. Here, where the central vent is, that's where the magma is rising usually. Sometimes it'll have little smaller veins and cracks and things. So those are called side vents. Down here, it's still magma, but once it bursts out onto the surface, we call it lava. And then sometimes there's a lot of hot gas, or the little ash, the little flaky parts, kind of like snowflakes almost, that fly up out. And the mouth or the rim of the volcano is called the crater. Okay, different types of material may be ejected from a volcano, and all of them are very hot. Lava may be hotter than 1,100 degrees Celsius, or 2,000 degrees Fahrenheit. Rock fragments dust, ash, steam, and a variety of gases can also burst from a volcano and scald anything in their paths. Okay, so let's write some of this. Rock, R-O-C-K, comma, ash, A-S-H, comma, steam, S-T-E-A-M, comma, gas, G-A-S, arrow, scalding, S-C-A-L-D-I-N-G, exclamation point. The rock, ash, steam, and gases that come from the inside of the volcano and explode out are scalding hot. Scalding hot would be like if you turned up your water heater so hot and you tried to take a shower at full heat and you reach your finger in and it burns instantly and it turns your hand red. That's scalding hot. It's like boiling hot water. Actually, boiling hot water is probably only around 200 or 300 degrees Fahrenheit. This stuff is 2,000 degrees Fahrenheit. This stuff is literally like 10 times hotter than boiling hot water. Inside an erupting volcano, a volcano may erupt through one or more side vents as well as its central vent. The mountain forms from layers of lava, ash, and other debris. Okay, I think we understand that based on our vocabulary terms and what we wrote here. New red header, volcanoes, capital V-O-L-C-A-N-O-E-S, and down 3 down, plate, capital P-L-A-T-E, tectonics, capital T-E-C-T-O-N-I-C-S. If you look at a map, you will notice that volcanoes seem to cluster in some areas. These are especially common around the rim of the Pacific Ocean. Okay, remember the Pacific Rim? If not, here's our picture, right? There's the boundary, the plate boundary of the Pacific Plate, and that's where a lot of volcanoes tend to exist. Okay, so capital P-A-C-I-F-I-C, capital R-I-M, Pacific Rim, plate, P-L-A-T-E, boundaries, B-O-U-N-D-A-R-I-E-S. So volcanoes tend to form at plate boundaries, for example, the Pacific Rim. Because so many volcanoes and earthquakes occur around the Pacific Ocean, it is often called the Ring of Fire. Okay, so the Pacific Rim is the ring, capital R-A-N-G, of O-F, fire, capital F-I-R-E. The ring exists because of the many plate boundaries there. Volcanoes often form at convergent plate boundaries. We remember that from before. In places where an ocean plate and a continental plate meet, the ocean plate is pushed under the land plate. Okay, so remember the ocean plate is out there in the ocean. The continental plate is the land. Typically, the ocean plate gets pushed underneath. So, here's the Pacific plate. That's an ocean plate. Here's the North American plate. It's a continental plate. When the two push together, the ocean one goes underneath, and that's how you end up with the subduction zones that cause all these volcanoes. As the edge of the ocean plate dives into the mantle, its leading edge melts into magma. Yeah, so it's diving down in, getting pushed down further and further towards the hot core, and it gets melted into magma. The magma rises and bursts through cracks in the crust. Okay, so the crust is not like perfect, right? It has cracks in it, so some of that stuff can rise up through the cracks. The volcanoes of California's Cascade Range formed in this way. All right, so magma, M-A-G-M-A, rises, R-I-S-E-S, arrow, cracks, C-R-A-C-K-S, indent, N-I-N, magma rises through the cracks in the continental plate, C-O-N-T-I-N-E-N-T-A-L, and then plate, P-L-A-T-E. Okay, going back to page 116, chapter 3, lesson 4, All the way back here is where we see examples of that. Here's the ocean plate or the oceanic crust. Here's the continental plate with its continental crust. The ocean part tends to get subducted down underneath, but eventually it can heat up and rise through cracks. And if it pools and collects enough, you get so much magma that it can burst through as a volcano. Okay, now island arcs are over here. Sometimes you'll get that happening underwater where two plates meet. And you'll get an island arc at a subduction zone that's both underwater. You can also get hot spots out in the middle of the ocean. So if I remember correctly, I believe those island arcs are how Hawaii and the Aleutian Islands formed. So you can see the dark black line. There's a plate boundary. And then you can kind of see that little line right there. And there is Hawaii. So that's what's going on. Okay, next up. Volcanoes also form where two oceanic plates meet. Hey, that's what we just talked about with the island arc. In this case, too, one plate is pushed under the other. A trench forms at the boundary. Just as when land sea plates meet, magma rises through cracks in Earth's surface. Okay, so let's go back to that page. What was it? 116. Two plates are coming together just like here, but one of them is not continental. They are both oceanic. They're both under the water. So you get a trench underwater, and you get an island arc forming where it builds up over time and eventually comes up past the surface of the water. So a chain of islands is built up from the ocean floor. Okay, we said all of that here. The Aleutian Islands of Alaska are an example. All right, compare different ways that a chain of volcanoes may form. Well, a chain of volcanoes can form when plates come together at plate boundaries, right? Convergent. So let's put that here. CONVERGENT. A chain of volcanoes may form at convergent plate boundaries. The difference is sometimes it's a continental plate and sometimes it can be two oceanic plates, like an island arc. Okay, so magma rises through the cracks in a continental plate, parentheses, or oceanic, OCEANIC, plate, PLATE. So when it's a continental plate, you'll get volcanoes on the surface. If it's oceanic plates, you'll get an island arc. Let's put that down here. ISLAND, arc, ARC. All right, that's everything for the first day. Good job persevering with the growth mindset and Roller Wildcats.